All right, this is what I love to do, throwing rocks off cliffs. I used to do this as a kid a lot. I used to live by a cliff that was about probably 35 or 40 meters from the river, and we used to throw and see how far we could throw the rocks. So I used to, you had to throw up a little bit higher to get it to go further. All right, so first of all, let's just make our drawing here. So this is our cliff, and so the rock is going to be launched off this cliff. So the cliff, I said, was at right about 90 meters. So I put that right here. This is 90 meters here. All right, that's from the water, okay? So this is the water here. And so when we launch that, we throw it, it's going to go up in the air, right? And at some point, this is not going to be the scale, right? It's going to go off into the water here, okay? So what we know is that at that point there, that it reaches a maximum height of, and that's at 20 meters from the bank, right? So 20 meters out, because that's what it says right here, 20 meters from the cliff, reaches a maximum height of 130 meters. Okay, so when we're given the vertex, we're probably going to want to work with vertex form, ideally. Okay. All right. So some things to maybe make note of is, like, if this is at 20 and 0, so over here somewhere, this is going to be at 40. So we know it's going to be something a little bit more than 40, and then we'll have, when we find the roots, at some point we're going to get a value here. All right. All right, so think about this. What do we have so far? Well, we have, so the dependent variable is the height. Okay, so that's the height. This is the height here. H of, I guess, D, distance. This is the distance, D. And this is the distance from the cliff. All right, so h of d is equal to, well, we don't know what a is. I guess we know that it's negative, but whatever it is. A is, and then we have in vertex form x minus h. H is 20. Squared plus k is 130. Okay, so what are we trying to find here? Let's see. We're going to make an equation. Well, we need to find out what a is. Well, we know that the height is at 90. That's actually that's a coordinate. So it's at 0, 90. That's this point right here, right? 0, 90. That's the starting point where we threw the rock from, okay? So why don't I substitute that value in? So I'm going to substitute 0 in for x, and I'm going to substitute 90 in for y, okay? So we have 90 is equal to a. So we have negative 20 here, squared plus 130. So we subtract 130 from both sides. Okay, so we have negative 40 equals 400a. Well, that works out nice. So when we isolate, we get a is going to be equal to negative 1/10. Okay, so I can come up with a function now for that, right? So I'm going to make an equation. That's one of the things that's asked. All right, so I'll just highlight that. This is the equation here. All right, so the equation is, let's go with purple. H of d is equal to negative 1/10. That's the a value, right? And x minus 20 squared plus 130. So there's our function. Now what we want to find out here is how far will it be from the base of the cliff when it hits the water. Okay, that's this point right here, the root. Okay, and the other root would be here, but again, that doesn't really exist, so we're going to rule that one out. So, well, that hits the water at a height of 0. So the 0 is the height. So 0 is equal to negative 1/10 x minus 10, or sorry, 20 squared plus 130. This, whenever we have a perfect square, I mean, the best method, rather than expanding all this, setting it equal to 0, and then using quadratic formula, let's isolate the perfect square. Okay, so subtract 130 from both sides, and so let's do that first. You could do more than one step at a time, I know, but I'm just going to slow it down a bit. All right, and then I'm going to multiply both sides by negative 10. Let me scroll just a little bit. Okay, so I'm going to get 1,300 is equal to x minus 20 squared. And then I'm going to apply the square root principle. Okay, I'll have x minus 20 is equal to plus or minus the square root of 1,300. Okay, so x equals 20 plus, plus or minus, square root of 1,300 is 36.1. Now, obviously, if I subtract, I get that negative, so that'll be like negative, I guess, what is that, 16.9 or something. So that number, we're going to rule that out. So we were only left with x is equal to 56.1. So what was that measurement in? Was it meters? Yeah, meters. All right, so this distance here is at 56, approximately actually, because we had to round that. It's irrational. 56.1 meters from the cliff. Okay, so we ruled this one out. We're not going to subtract and get a negative distance from the cliff. Did we answer the question? Yeah. Okay, that's good. Does that seem reasonable? I mean, because this is 20 meters here at the vertex. So when we get to the cliff height, which is 90 meters, we're already at 40. And then it's going to drop another 90 meters. And it's obviously carry on that same kind of momentum. And then eventually hits the water. So about another 16.1 meters from that point. All right. Nice question.